What is one cycle? One cycle means this much here. Now, what about RMS value of this function? Sine or cosine, will it be same? Because till now I just discussed only sine wave, no? So let me introduce the cosine function here. One cycle is what I'm showing it here. Now you have to be careful. First, how the current will flow? Current will flow in one positive direction for t by 4 seconds. Then it changes direction. For another t by 2 seconds, it will be in negative direction. Again it will come. Again what means the current will flow in positive direction. So 0 to t by 4, then t by 4 to 3t by 4, opposite direction. Again 3t by 4 to t, again in opposite direction, that one. So current will alternate. This is also an AC signal only. This is one cycle. One cycle or one time period. So this part of graph is what will repeat again and again. Check it. So what is the equation for this? I is equal to, we write like this, I naught cos omega t. Let's go back to the basic formula. RMS square is equal to, now what should be the one cycle? 0 to t only. This is one cycle. This is a time period of this signal, or the range of this signal, what you can call it mathematically. Let's substitute here. This will be, numerator will be 1 by t. I naught square I'll bring outside. So this will be RMS square equal to I naught square by t cos square omega t. One plus integral of, this should be integral of cos omega t will be, so let's substitute all the limits, then we'll see how this function will end up. This will be t plus t by 4 pi upper limit, then lower limit will be, so this the whole thing again, the bracket, this particular thing cos 4 pi t by 0 to t will be 0 only. So what is the equation I'm ending up? I naught square by 2t. So either it is cosine or sine wave. What is the RMS value? Will be same. RMS equal to I naught by root 2. Please do notice these are very important. So small basics, because we just carried away only by sine wave, cosine wave. Means what is the RMS value of any difference between sine and cosine? Some phase difference. Shall I call just a phase difference? Means what is the RMS value of all such signals where they're having some phase difference between them? I'll scroll to next page. There's a basic sine wave. Next, I will take cosine wave. Amplitude should be same, no? Then I'll bring another wave. Another wave will be, so there are three waves, what you can see. This is I naught. There's a time in seconds. So we'll give name for them. 1, 2, 3. What is I1? You can write it. I1 of t is I naught sine omega t. What about I2 of t? I naught cos omega t. And look at this. This is having some phase, no? What about I3? I3 at t equals 0, what is the value of I3? Will be 0 after some time, or if you extend back this, actually you have to extend back this one. So at t equals 0, what is the value of that one? It is negative here, no? So when you substitute t equals 0 in the function, what you should get? You should get some negative value and negative value, and it should be finite, some value, that one. So this particular thing is what we'll call some phase difference. So which will come first? I think the cos, this is having more phase 90. This is having a phase of -5. This will be, so I'll do right equation. I naught sine omega t -5. Put t equals 0. It's having some negative phase. You can also bring another wave starting from somewhere here. We can also bring like this and all. So there's like a phase lag. Put t equals 0. So we'll get that negative value, that one. So like this, we define a signal. What is the RMS value of all this? Will be same. They're having a phase. The phase doesn't matter. Cos omega t, can you write in terms of sine omega? Plus 90 degree plus pi by 2. Is it justified? It should be equal to plus pi by 2, that one. So the same equation, we can also write it as, put t equals 0. So I naught sine pi by 2 will be 1 plus I naught. So what is the phase of this signal? Pi by 2. What is the phase of this? -5. So like that, we can define the phase of a signal. So what is the use of phase? The phase will define the instantaneous position, the instantaneous value of current at that instant of time. Go back to SHM, already we discussed the phase in waves and sound, and also in SSM chapter. So here also we'll bring it here. So like this, I can compare signal. What is the RMS value of all this? For all the signals, what is the RMS value? Will be same again. You do get very simple questions in exams. They'll give three different signals of three different phase. They'll ask you compare the RMS value. RMS value is independent of phase. Shall you